I'd like to continue the idea of representing a linear function today and show you how to graph using a table. Okay, so an important point here is that you need to make sure that every time you want to graph using a table, you have to solve for the dependent variable. Okay, solve for the dependent variable. So imagine if I have the following equation. 2 times y equals 3 times x minus 4. This is not completely solved yet, and y is your dependent, so if you want to solve for it, you've got to divide it by 2, y by itself, dependent by itself, so that's going to give you 3 over 2 times x, and of course this is negative 4 times over 2, right? And then you can simplify some more, which is this, okay? So now if you want to put this back into a table format, you would go ahead and set it up this way. I should actually put the definition instead. This is 3 halves times x minus 2, and this is whatever you got back is your output. So here, unless I provide you with with inputs, you can use those. If not, you've got to provide your own. Now, be wise about what you want to pick for your inputs. You want to pick numbers that are easy for you to evaluate. For example, I'm going to pick mine as negative 2, 0, and 2. The reason I'm picking 2 or negative 2 is because it can't be cross-canceled with the 2 below here. Okay, so when I substitute it, this cross-cancel will give you negative 1. Negative 1 times 3 is negative 3. Negative 3 minus 2 is negative 5. And then next number, 3 halves times 0 is 0. 0 minus 2 is negative 2. Last one, 3 halves times 2 minus 1, which is 3 minus 2, 1. Okay, if you ever want to graph a line, I know that the bare minimum requirement is 2 points, but you know what? Don't be lazy. Get at least 3 points. Okay, unless I specifically just ask you for 2, but get at least 3. So now you got your points, input, output combined together. So negative 2, negative 5, 1 point, 0, negative 2. I got 2 and 1. Okay, I have enough information to plot these. So it's going to be negative 2, negative 5, 0, negative 2, and 2, 1. Notice when I connect these 3 points together, I have a linear function, okay, because it passed the vertical line test first of all. And if to go back and review with you here, the function is this. If I ever want you to put it back into standard form, that means you've got to move the 3x over, so subtract it over, which means you have negative 3x plus 2y equals to negative 4. Don't forget, I don't want to have a negative in front, so to fix that, you would multiply the whole thing by a negative number, which becomes 3x minus 2y equals to positive 4. This is in standard form. Okay, that's this in standard form, which you can kind of see it is a linear function and it follows a format. The form that we just solved earlier here, I might as well just give it a name already, where the y is by itself and the x is on the other side with the number, or the constant, is what we call a slope intercept form. So don't worry about that for now. I'm just giving it a name, but kind of keep that in mind though, because we will definitely going to talk about slope intercept formats. So 2 forms that I need you to be aware of. Standard form, which is all the x, y to one side. Slope intercept format, just the y on one side. Okay, so keep that in mind. So I guess that's it for the graphing a function using a table form.